All right, let's get into it. Today, we're going to pull back the curtain on the tech that pretty much runs our entire digital world, the database. We're going to look at the core ideas that built this tech and see where it's all headed. Let's dive in. I mean, have you ever really stopped to think about it? How does your shopping app remember what's in your cart? Or how does your bank track every single transaction perfectly without missing a beat? It's not magic, right? It's an incredibly powerful system working behind the scenes. And that system, well, that's the database. It is the silent, invisible engine that is constantly storing, organizing, and retrieving just massive amounts of data that make our modern lives work. So, to really get a handle on this, here's what we're going to cover. We'll look at why they're so essential, what they're actually made of, how the whole system fits together. We'll take a quick trip back in time to see where they came from, and then look at how they scale for today's world. Okay, so first up, let's just appreciate how deeply databases are woven into everything we do. They really are the engine that runs pretty much everything. And when I say everywhere, I mean it. You've got the checkout system at the grocery store, your shopping cart online, even the contact list in your phone, all databases. But it's way more than just simple lists. We're talking about the huge systems behind business dashboards and even the complex data mining that companies use to predict future trends. So we know they're everywhere, but what's the big idea that separates a real database from, say, just a folder full of spreadsheets? What's the secret sauce? Well, it all comes down to the fact that a database understands itself. And to understand that, we need to look at their basic blueprint, the thing that makes them so incredibly powerful. Here's the key idea. A database is self-describing. What that means is that it contains its own blueprint, what we call metadata. This isn't just data about the data. It's the entire rulebook. It defines the structure, enforces constraints, and keeps everything consistent. It's what lets the system manage itself. And this self-describing structure is what lets a database turn raw data into useful information. See, you start by storing data in tables, but then you create relationships between those tables using keys. All of a sudden, you don't have isolated facts anymore. You have a web of context. Then you can run queries that pull from all these connected tables to create insights you'd never see otherwise. Okay, that makes sense for the database itself. But that's just one piece of the puzzle. How does it all connect into a system that a person can actually use? A complete database system really has 4 essential parts, and they all have to work together perfectly. You can think about it in layers. At the top, you have us, the users. We never touch the database directly. Instead, we use an application, a website, a mobile app, whatever. That application then talks to the brain of the operation, the dbms, or Database Management System. That's your Oracle, your SQL Server. The dbms is the ultimate gatekeeper, and it's the only thing allowed to actually touch the database itself, handling security, performance, and keeping the data safe. This clean 4-part system seems so logical now, but it didn't just pop into existence. It's the result of decades of trial and error. So, to really appreciate it, we gotta look at where it all started. Yeah, the journey from just a bunch of disconnected files to the systems we have now was a long one. Let's do a quick walk through the major eras of how we've processed data. The 70s were basically the Wild West. People had databanks, but there was no formal structure. Then, in the 80s, the relational model came along and brought order to the chaos, with companies like IBM and Oracle leading the way. That model was perfect for structured business needs. A bit later, it made its way to personal computers. But fast forward to now, with the internet and social media creating this explosion of messy, unstructured big data, the rigid relational model couldn't keep up. And that pressure is exactly what sparked the flexible, NoSQL movement we see today. So this whole evolution has left us in a really interesting place. We've got databases that can run on a laptop, and we've got databases that power the entire globe. So what's really the difference between them? Well, it really just comes down to 2 different classes of database systems, each one built for a very different job. On one side, you have personal systems like Microsoft Access. You can think of it like a Swiss Army knife. It's got the database engine and the tools to build forms and reports, all in one package. It's perfect for a single user or a small team. But then you have enterprise-class systems, Oracle, SQL Server, MySQL. These are not Swiss Army knives. They are pure industrial-strength engines. They are built to do one thing, support thousands of users and incredibly complex applications with high performance. They don't have built-in tools. They are just the raw power that your custom-built applications connect to. So we've seen this incredible evolution, from simple files to relational models to distributed NoSQL systems. And every single leap was a reaction to new demands. So that brings up the big question. With AI, machine learning, and the cloud pushing data to its limits, are we on the verge of the next great shift? What does the database of tomorrow even look like? Maybe the next chapter won't be about storing data at all, but about processing it in motion, creating systems that can learn and adapt in real time. It's a fascinating challenge, and it's absolutely going to define the next decade of technology. Hey, if you enjoyed digging into this with me, please hit that like button, share this, and subscribe for more. Thanks for watching.